good morning. As promised, the next topic will be more focusing on the different types of boundaries. So today we will begin discussing the different types of plate boundaries, its effect to the Earth's surface, different landforms formed on each plate boundary. So we will begin with convergent boundary. Convergent boundary, this type of plate boundary is also called destructive plate boundary. Later we will discuss why it is considered as destructive boundary. It occurs where two plates are pushing towards each other. So here the crust is destroyed and recycled back. So that is why it is referred to as destructive, because two different plates are actually acting against each other. So one of which, or one of the plate will be totally destroyed, while the other one will be recycled back into the interior of Earth, while one plate dives under the another plate. What happens to the crust when two plates are converging? So as I've said a while ago, it is considered as destructive because one plate is totally recycled back into the Earth's interior. So which means it is actually destroyed and becomes part again of the Earth's interior. So when a moving plate of dense oceanic lithosphere, again, in between the convergence of oceanic and then continental, it is always the oceanic crust which will subduct because it is much denser. Now, in between oceanic to oceanic convergence, again, in between the two, since both of them are actually dense, which means there will be still one oceanic or one denser oceanic plate that will subduct or submerge towards the Earth's interior. With the plate moving in the opposite direction, one of the plates subducts or submerge beneath the other. The younger of the two plates, which is actually considered as the lighter one, will ride over the edge of the older plate because the former is less dense. So in between the interaction of the two plates, again, there will be one which will subduct and then the other will override the other. The heavier plate, again, which is the oceanic crust, eventually bends and plunges steeply through the asthenosphere and descends into Earth, creating a trench that can be as much as 100 kilometers wide, more than 1,000 kilometers long, and several kilometers deep. So, trenches are actually the deepest part of the ocean due to, we do know that the ocean floor is, or ocean basins are actually deep or hard to dive into by some divers. But then again, due to this interaction of plates, there will be a much deeper portion of the Earth due to this interaction, because the oceanic plate will be the one to subduct. Thus, it will create a much deeper portion than its ocean floor, which will be the trench. Less dense plate will subduct to the mantle. Is it true or false? Okay, I hope you do know the answer of that because I will include that on my quiz. Again, less dense plate will subduct to the mantle. The answer to this is actually false. The one which is actually denser will be the one to subduct to the mantle. The one which is much heavier and denser oceanic crust will subduct to the Earth's interior. So such as this one on this figure, as you can see, there are two plates moving towards each other on this particular area. So on this interaction, as you can see, it is covered with water, which means this interaction happens on the ocean floor. Okay, because you have water on top of it. So this one is an oceanic crust, which means this is an interaction between oceanic crust and another oceanic crust. You look what is the effect in here. It created a trench due to the ocean floor is deep, no? But then again, due to this interaction, it will still subduct due to its density or denser property. It will subduct and then go back to the Earth's interior. Now, on this part, there is this portion that is some parts of the oceanic crust on this region is totally destroyed and then go back to the Earth's interior. Okay? But then again, on the other part of it, as you can see, since it will go back to the Earth's interior and becomes part of the magma because it's so hot that it melts and become part of the magma, as you can see. On this case, it will go back again and create a new crust. Okay, but we will have a different discussion on this because these plates move away from each other. Let's proceed. Subduction zones are the regions where a portion of the tectonic plates are diving beneath other plates into Earth's interior. These zones are defined by deep oceanic trenches, large earthquakes that extend from the trenches landward, and lines of volcanoes parallel to the trenches. So, as you will observe, most of the effects, of this oceanic to oceanic convergence, one effect would be formation of trenches and of course lines of volcanoes. So these are actually series of volcanoes parallel to the trenches. Because as you can see, based from this figure, if this is your trench, there will be a production of magma on the other side or parallel into the formed trench. So in here, there will be a series of volcanoes formed on the area. Okay? So, the Wadati-Benioff zone is an example of subduction zone. Earthquakes in this area may extend down to depths of 100 kilometers before the subducting plate heats up and loses its ability to deform in a brittle fashion. So again, what can you find on subduction zones? Firstly, you will find trench, and then of course line or parallel to the trench is actually lines of volcanoes. So do not forget that. So this one is an example of Wadati-Benioff zone. Ayan. So on the Wadati-Benioff zone, as you can see, there are a series of volcanoes or lines of volcanoes parallel to the trench formed. So in this particular portion, earthquakes are very, very frequent to occur because this one is a very active zone. You have trench plus you have series or lines of volcanoes parallel with respect to one another. Now let's proceed with oceanic to oceanic convergence. When two oceanic plates meet and one oceanic plate is pushed underneath the other, during the process of subduction, the subducting plate descends into the mantle. So again, there will be one denser plate which will subduct and forms your trench or subduction zone. Due to extreme temperature, the plate is heated and magma is generated. As magma is less dense compared to the surrounding rocks, it rises up. Okay? Now, on the ocean floor, through eruption building arcs of volcanic islands such as the Japanese Islands, the Aleutian Islands, the Caribbean, and the Philippine Islands. So, in this formation of oceanic to oceanic convergence, landforms formed are actually islands. Likewise, together with that formed island is actually volcanoes. Because as you can see, very prominent on the case of the Philippine Islands, we have series, three, or to be specific, three huge islands, the Luzon, Visayas, and Mindanao. And together with it are the huge volcanoes that are distinct from one island to the next. Okay? So those are the landforms formed, or very prominent feature that you will observe under oceanic to oceanic convergence. So apart from trenches, there will be islands formed and volcanoes. So give specific islands which forms through oceanic to oceanic convergence. So as I've said a while ago, we have Caribbean, Aleutian, Japanese, and likewise the Philippines. So Philippines is formed under the category of oceanic to oceanic convergence. Next, so this one is an example of oceanic air. As you can see, there is a water on the topmost portion, so which means on this interaction you have two different plates, two oceanic plates that is pushing towards each other. The oceanic crust, one oceanic crust which is denser, plunges towards the Earth's interior. Now the interaction, we discussed this one already on the discussion of volcanoes during your grade 9 years. Now, the interaction between these two plates, one will subduct and then the other will just override the other, releases heat. It's actually a very tremendous heat, and this heat is enough to melt the rocks that are actually subducting. And since the magma is actually, or the molten rock, as an effect of this release of heat on this area, it forms magma, and as we do know, magma are actually less dense than the surrounding rocks. Thus, it rises up and create volcanoes. Okay? Now, sometimes it's actually series of volcanoes or lines of volcanoes, because as you can see from the trench in here, parallel to that is actually lines of volcano. Okay? And then this one is actually rift or cracks due to an intensive pushing against each other on this area. So there will be an expanded area on this, because most of the particles or most of the rocks or interaction is actually focused on this area. Thus, on this area is actually an expanded area. Thus, there will be cracks or fissures formed on this area. Now, you have here trench form, and then you have the accretionary wedge. These are actually materials formed as an effect of the overriding of one plate atop of the other plate, which is actually subducting. Okay? Now, this part is referred to as the forearc. This one is the magmatic, wherein there is an intensive release of magma on this area as an effect of the release of heat in creation of magma on this area. And then on the backmost portion of this entire continental to continental convergence is referred to as the back arc. Okay, again, forearc, magmatic area on the middle, and then the back arc, or fissures or cracks formed on the ocean floor. There are several structural and topographical features created at many subduction zones. So the first one is actually a swell. This is actually a bulge in the descending plate known as an outer swell. Commonly develops where the plates bend to dive down the mantle. So these are actually an effect of the subducting plate, and then the other one is overriding atop the other plate, which is subducting. Closer to the island arc, a deep trench, a forearc ridge can be formed. Traps sedimentary deposits and are underlain by faulted and highly deformed sedimentary and metamorphic rock. So again, let's go back. This is your forearc ridge. Okay? Okay, going back. Closer to the island arc, a deep trench of our arc ridge can be formed. Trapped sedimentary deposits in the underlain by faulted and highly deformed sedimentary and metamorphic rock. The back arc, which is located behind the volcanic arc, is a broad region of variable character that may be compressed or extended. So sometimes if it is extended, you may find some rift or cracks or fissures on the ocean floor just behind the volcanic arc, or lines of volcanoes parallel to the trench. Again, what is a back arc? These are sometimes extended or compressed. If it is extended, you may find rifts or cracks or fissures on at the back of the volcanic arc, or lines of volcanoes parallel to the trench. So this is again an example of oceanic to oceanic plate convergence. As you can see, this is the Pacific plate converging with the slower moving Philippine plate. So this one on this side, you will see the Pacific plate, and then on this side is actually the Philippine Sea plate. So as you can see, you have here the trench. So if this is the trench, just parallel to the trench is actually series of volcanoes. But then again, since it occurs on the ocean floor or in between two oceanic to oceanic plate collision or convergence, it will create a trench. Parallel to that are actually lines of volcanoes or volcanic arc. And then you have here, let's have this one is a 4 arc, the volcanic arc. And then you have here you have here a crack or fissure or an expanded form referring to your back arc. Next is actually the oceanic to continental convergence. Oceanic to continental convergence occurs when an oceanic plate pushes into and moves underneath a continental plate. So in between the two, the oceanic plate will be the one absolutely going down or submerges or subducts, because the continental plate is lighter. Again, on the rule, it is always the one which is denser that will subduct and go back to the Earth's interior. The continental plate will be the one to override the oceanic plate, lifts up to create mountain ranges. As the oceanic plate sinks, it glides into the newly formed trench and smaller pieces break off. Again, on this case, what type of plate overrides atop oceanic plates forming mountain ranges? So, that would be continental plate. Next, as you can see on this figure, this one is actually your continental crust against the oceanic crust. Now, in this case, again, you have a trench, you have a subduction zone, you have series, you will still form here. If it is not a volcanic arc, you will form a mountain ranges. Okay? Again, still, why, teacher, that you will still form, or on this particular convergence, there is still formation of volcano? Because on the subduction zone, may I reiterate on this, the interaction between the one which is subducting and then the other one which is actually overriding the atop of the other plate, it creates, this one is actually having a friction, an intensive friction against each other, because there is a collision in here. Now, the friction releases an intensive amount of heat. That heat melts the rock and form your magma on this region. Now, if on this particular region it forms already a magma, the magma is actually denser, absolutely denser from the surrounding rock. It will go up and form your volcano. Okay? So, in line again with the formation of your subduction zone, it will absolutely form a volcano. Because the interaction between the two is having an intensive type of friction. The friction releases heat. The heat melts up the rock and leads to the formation of magma. The magma is denser, lighter from the surrounding rock. Now, on that case, it will go up because it is lighter and forms volcano in here. Okay? Or lines of volcano are also known as volcanic arc parallel to the trench. These small pieces are locked in their place for a long period of time before they produce sudden movements in earthquakes. Some of the landforms created by the convergence of oceanic and continental crust are the Andes Mountains in the western South America. We're done discussing this one with different belts on the first 3 meetings that we had on the opening of our class this year, 2020. So, kindly do have a brief recap so that you would have a view of this mountains that I will mention on this discussion, or some volcanoes that I will mention on this discussion. So, you have Andes, the longest mountain range on the Southern America, Cascade Range in Western North America. Now, this one, remember the Andes Mountain Range, the longest mountain range on the Southern America. And then this one is a Cascade Range acting against your one defocal ridge or plate. This one is found on the Pacific Plate. And then you have here the Mount St. Helens. Remember our discussion during our grade 9 years, wherein we discussed the Volcano Eruption Index, or the one which measures the most eruptive volcanoes in the whole world. Mount St. Helens drops on the 3rd rank. First one is actually during the early period, 79th century. And then the second rank is actually here on the Philippines, which is actually Mount Pinatubo. 3rd rank is actually Mount St. Helens. That is actually under the Volcano Eruption Index. So this one is one of the most active volcano in the whole world. Next, give 2 examples of mountain ranges on this type of convergence. You have Andes and Cascade Range. Continental to continental convergence. Continental to continental convergence occurs when 2 continents meet head-on. This type of convergence is different from oceanic to oceanic convergence, as continental crusts are too light to slide down into a trench. Okay? Since both of them are light, then there will be no subduction form because in a subduction, denser plate will go down and form your subduction zone or subducting plate. On this case, both of them are light, thus no plate will subduct, thus both of them will go up and forms your mountain ranges. See this one? You have here the continental crust. Against continental crust, there is no subduction formed in here, thus you will not form here any volcano. Again, because on subduction zone, the interaction again is having an intensive friction. Friction releases heat. The heat melts the rock. The rock that is molten is actually magma. Magma is the lighter from its surrounding rock, thus it will go up and form your volcano. But as you can see here, there is no prominent figure that will show us that there is a subduction zone on this area. It will just become part of the ancient oceanic crust, or again become part of this asthenosphere. Okay? This type of convergence is different from oceanic to oceanic, as continental crusts are too light to slide down into a trench. Of course, this one is true. As such, neither plate is pushed underneath the other. So, neither. The result of convergence is the formation of tall mountain ranges. The Himalayas, known as Earth's highest mountain belt, is an example of a zone of mountains that rose when India collided with the Eurasian continent. So this one is a picture of the Himalayas, one of the highest mountain. No, this is the highest mountain range in the world, for it contains world's tallest mountain, such as the Everest. Give a specific example of landform which forms true continental to continental convergence. Again, that is Himalayas. So, okay. So, the next boundary that we're going to discuss is the divergent boundary. So, one distinct property of this is that two plates, either continental or oceanic, move away from each other. So, it is possible that on the ocean floor, two oceanic plates move away from each other, and this leads to the formation of huge fissures or cracks on the ocean floor where magma, as you can see on this area, this is the ocean floor. As you can see, it's very visible. That is because it is represented by color blue, which means it is covered with water. And as you can see, you look, two oceanic plates move away from this portion, oceanic crust, and this pave way for the release of magma on this region. So every now and then there is an observance of magma released on this region. As an effect, there will be a formation of series of little mountains or of series of volcanoes underneath this portion, or on this portion rather. Iceland actually is formed through the divergence of North American plate moving westward, and then the Eurasian plate moving eastward. So as you can see on this figure, there is a continuous release as of this moment. Still, there is a continuous release of magma on this region. Thus, this particular size of Iceland is continuously increasing by size. Okay? So, again, Iceland is formed right through this mid-Atlantic ridge system. This is the ridge system that I am referring to. Ridges are actually series of mountain formed through the opening in the ocean floor through divergent boundary. So when this North American plate move westward and then this Eurasian plate move eastward, it paves way for the rising magma and leads to the formation of an island on the topmost portion. Successfully up to this moment, there is a continuous release on this portion. Thus, there is an island formed on topmost, and on this case, that would be Iceland. But there are some cases the magma is not continuously releasing on that particular portion. Thus, it will just maintain on, it will just stay on the ocean floor and forms little mountains, series of little mountains on the ocean floor, series of little volcanoes on the ocean floor. Now this is another picture of the mid-Atlantic ridge. As you can see, it's actually a line, a huge line of crop on the middle, wherein lots of magma is released on this area. And as you can see, as an effect of release of magma on these cracks, there is actually a formed land. Sometimes it's a series of mountain, sometimes it's a series of volcanoes just beside the croc or the divergent boundary. Now, if it happens on land, it is referred as a rift or cracks or fissures on the continental crust. It's just like on the East African rift. On this case, let's have this one. These are the plate boundaries. That would be the Arabian plate. And then of course, the African plate in here. And then you have here the East African rift zone. Thus, the separation between the African plate and then the Arabian plate on this side, the moving away from each other of these two plates, Arabian and then the African plate, creates this rift zone or cracks. These are actually lines of cracks or rift. You may also call that one as a rift, where there is cracks, lines of cracks or fissures or holes on the continental crust. On this case, that would be the East African plate, continental plate. So, another picture, this is a picture of the East African rift. As you can see, there is the crack. This one is the crack or fissure in between the East African plate, the African plate, and then you have here the Arabian plate. Next would be, and the last would be the transform fault boundary. This one is a tectonic boundary where two plates slide past each other. So, an example of which is the San Andreas Fault, which is actually a huge 1,200 kilometer long fault system right through the city of California. You know how well developed, well industrialized is California. So on this case, likewise, how populated it is. Now, when this very long fault system moved, it will affect the whole city of California. Of course, establishment will be totally doomed, and a lot of casualties will result into this kind of movement. So as you can see, this is the one picture of San Andreas Fault system, wherein it shows that it's actually a very long and narrow type of fault system that travels through the city of California. So this is actually under the category of strike slip, wherein two plates slide with respect to one another. So what are those two plates? You have here the North American plate, and then this one is the huge and the largest Pacific plate. The interaction between the two, or the sliding past against each other, as you can see, Pacific plate is heading northward, while North American plate is heading southward. And as an effect of that, there is a huge crack in here, which is actually your San Andreas Fault. So this one is how long San Andreas Fault is. It is actually a 1,200 kilometer long fault system. So, and it passes through, as you can see, it passes through the entire California. And as you can see in here, this one is Los Angeles, which is known as a very known city for gambling. So if that would happen, a lot of establishments, business establishments, to be specific, that will be totally destroyed if that happens. Because this one is an interaction between two huge plates, which are actually the North American plate and the biggest one, which is the Pacific plate. The San Andreas Fault is a continental transform fault that extends roughly 1,200 kilometers or 750 miles through the city. As in through. It passes through the city of California, the entire city. It forms the tectonic boundary between Pacific and then the North American plate. So that's all for today. I hope you've learned something new. although the topic is very, very broad. That's all for today. Goodbye and thank you, class.